The year 2020 has been marked by the departure of the giants. First was Airbus, announcing the imminent end of production of the A380. Then Boeing followed suit, deciding to retire their pride, the Model 747. The next one in line for Boeing, in terms of size and showiness, stands the Model 777. Precisely this plane is bound to become both the flagship model of the company and the largest mass-produced airliner in the world. As a testament to its superiority, it's being updated to a new generation. It's time to get to know this new airliner and see if it deserves its top spot. Hello aviators, Sky here, and I present to you the next-gen Boeing 777. So, the Boeing 777X is the third generation of long-range, wide-body airliners of the 777 family, developed by the Boeing company approximately now. History. The story of the new generation started in the 2010s, when Boeing was actively promoting its latest 787 Dreamliner, while Airbus presented the A350 XWB. Both of these airplanes became a real breakthrough for commercial aviation. Top-of-the-line wide-body twin jets that embody the most advanced technologies and solutions. Due to a vast number of similarities between these planes, many laymen consider them to be direct competitors with more or less same features. The reality is a bit more complicated. Let's take a look at some figures. The Boeing 787 is a family that includes 3 models, 8, 9 and 10. Their maximum takeoff weights range between 228 to 254 tons, while the standard capacity in a 2-class configuration varies between 242 and 330 passengers. Since these planes were designed for long-haul flights, they have a maximum range of 14,000 kilometers or 7,600 miles. Its counterpart, the Airbus A350 XWB, is also a family that consists of 2 models, the 900 and 1000. Their maximum takeoff weights range between 280 and 316 tons, with a capacity of 315 and 369 seats respectively. Their flight range sits between 15 and 16,000 kilometers, around 8,500 miles. So, what do we see here? The airliners of both companies coincide in their capabilities, but it is evident that the European brainchild is heavier, has a larger capacity, and flies farther than its quote-unquote rival. This can lead to the conclusion that, after all, the A350 is probably just better. There is no doubt that it is one fine plane, but the conclusion is wrong. The airliner does have a competitor. It is not the Dreamliner, but its older brother, the Boeing 777. The Boeing 777, also known as the 777, is the culmination of the twin-engine wide-body airliner concept, and it is also the biggest one of this kind. By the industry standards, the 777 is in the prime of its life. It is not the newest plane, but it is not even close to being old. This aircraft was developed in the mid-90s and kicked up a fuss by reimagining the market in quite a significant way. Needless to say, in over 2 decades, this aircraft has undergone lots of upgrades, which nominally split it in 2 generations. The first one came about in the 1990s. It was the basic 777-200 model, its long-range modification 200ER, as well as the buffed-up Model 300. The second generation was born already in the 2000s. The throne was inherited by an upgraded trinity, the long-range Boeing 777-200LR, the big boy 777-300ER, and the cargo 777F, which has a shorter range but can lift up to 102 tons of cargo. It is not the Galaxy, of course, but it's getting there. To say that the 777 family is a success is quite an understatement. Since the beginning of its deliveries in 1995, more than 1,600 airliners of all versions have seen the skies. Keep in mind that we're talking about quite complex and expensive machines. They have a price tag of well over $300 million. And then, all this beauty finds itself in the beginning of 2010s, when the A350 comes into scene. The Airbus creation ended up sitting right in between the 787 and 777 models, and it successfully competes not only with the smaller Boeing, but also with its bigger brother, and that is just shameless. The European's courage comes from its level of technological advancement, which brings along great economics and performance. In fact, the 787 in its Model 10 also became a problem for Boeing. It did not directly compete with the smaller versions of the 777, but it did land pretty close to them. The guys from Seattle became aware of this problem rather soon, and they started to develop a solution. The idea was simple: carry out a large-scale modernization of the 777 family, which would essentially result in the creation of the third generation. A better economy and flight performance had to be achieved with the help of cutting-edge technological solutions, many of which could be borrowed from the Dreamliner. The upcoming 777-8X had to replace the 200s, while the 777-9X would respectively replace the larger 300s. The competition in terms of passenger seats would be solved in the most obvious manner. Each new model was a bit larger and had more capacity than their predecessors. Works on the project technically began in 2011, but were carried out silently and relatively slowly. Most of the resources were dedicated to finishing other programs. It was quite a busy time. But the project went on. Most of the Boeing divisions participated in its development, both in the US and abroad. The 777X program was officially announced at the Dubai Air Show in 2013. That year, Boeing scored 259 orders, with a total cost of just under $95 billion. The main stage of development lasted several years. The design of the basic 777-9 model was frozen in 2015, and it took another 2 years to prepare all the technical documentation, so the construction of the first prototype began in 2017. Design. Okay, let's take a closer look at what they've created. In spite of being a cutting-edge plane, the Boeing 777X configuration remains committed to the classic configuration of commercial airliners. It is a wide-body aircraft with a slightly swept low wing, 2 turbofan engines suspended under the wing, a tricycle landing gear, and of course a classic tail. The first thing that the aviators did to the fuselages was to stretch them, thus increasing their capacity. The old airliners of the version 200 have a length of 63.7 meters, or 209 feet, and can take in about 310-320 passengers in a two-class configuration. The Model 300 airframes are longer and more spacious, with a length reaching 73.8 meters, or 242 feet, and a capacity of 396 passengers distributed in two classes. Meanwhile, the airliners of the new generation have stretched fuselages, so they are a step above in terms of capacity. The 777-8 is 69.8 meters long and can fit 384 passengers in two classes. At the same time, the 777-9 has a length of 76.7 meters and is meant to take 426 people on board. It is the largest twin-engine airliner and the longest airliner overall. Even the 747-8 turned out to be shorter. Just by a bit, but still shorter. The second stage was all about playing around with materials. Here Boeing showed its conservative side and did not rush to build a composite fuselage like with the 787. The Dreamliner is an entirely new airplane, and its airframe had to be built from scratch anyway. But the 777 is already here, with the manufacturing process set up and the industry already adapted to operate the classic versions. An overly deep modification would be an extremely complicated and costly enterprise, which obviously did not fit with the framework of the 777X program. After all, what we have here is a new generation, not a completely new plane. However, its fuselage is far from being the same. Most of the elements of both the structures and surfaces are made with new alloys. The amount of composites used is not beating any records, but they nevertheless allow to make the structure more light and optimized. The results of this work are seen both in figures and externally. Let's begin with the bonuses for the passengers. Even though the diameter of the fuselage is the same as before, 6.2 meters or 20 feet and 4 inches, new materials and improved finishing allow to increase the internal diameter to 596 centimeters, 234 inches, which is 10 centimeters more than before. Yeah baby, $5 billion were not invested in vain. The second and more obvious bonus of using improved materials are the cabin windows. They grew in size by about 15% compared to the old 777s, and by a whopping 29% compared to the windows of the A350. It is a passion of all aviation companies to see who's got the biggest window in an airplane. Naturally, the cool features, like the electrochromic glass from the Dreamliner, migrated here automatically. Among other improvements there are a more silent cabin, new interior design, new overhead bins, illumination, temperature control, higher cabin pressurization, comfortable humidity levels. All of these are the benefits of the improved fuselage and some solutions inherited from the Dreamliner. You might not feel them right away, but on a 12-hour flight, these features may just come in handy. The major innovation of the Boeing 777X is its new wing. It is almost completely made of carbon composites. On one hand, this allowed to reduce the mass of the structure, and on the other, vastly improved the aerodynamic efficiency. Most of the solutions came from the 787, but here the wing is bigger, a lot bigger. The wingspan of the Boeing 777X reaches 71.8 meters, or 235 feet. This is 7 meters more than it was in the airliners of the previous generation, and almost 3.5 meters more than that of the Boeing 747-8. Essentially, the wings of the new 777s are larger than any manufactured before by Boeing. Such an elongation drastically improved flight performance, but became a problem on the ground. The thing is that in such ground operations as taxiing, parking, entering the hangars, and so on, the dimensions of the plane are of great importance, especially the wingspan. The biggest airplanes, such as the Boeing 747, Airbus A380, AN-124, and the Galaxy C5, require lots of space. This creates additional operational requirements and limitations, increases operational costs in the airports, and at the end of the day, makes life harder for the pilots and ground crews. In this regard, the Boeing 777 had an easier time, with its wingspan of just under 65 meters, 213 feet, and it felt completely comfortable among such machines as the A340. But with the new wing, it would not fit in those old spots, which could lead to serious costs for the operators. Nobody even thought of making a smaller wing, as it would downplay the benefits of using composite materials. So the aviators came up with a breakthrough solution, which was implemented 100 years ago in the naval aviation. Aircraft carriers are some quite cramped airfields, and the airplanes on board are fitted with folding wings. This is what Boeing decided to do with the wingtips, which greatly increased the wingspan of the 777X while being relatively simple and light. The new wingtips are attached to the wing with hinge fixing and can be lowered or retracted by electric drives. They have several strong locks that reserve each other, so that, the wingtips wouldn't fold mid-flight. The configuration is changed while on the ground, before takeoff and after landing, and it takes roughly 10-11 seconds for the wingtips to fold, or around 20 seconds if we include the time needed for them to lock in their position. The new mechanism and lots of additional metal do not simplify the aircraft, but make it much more interesting and solve the problem of the excessive wingspan. The unfolded wing has a span of 71.8 meters, which goes down to 64.85 when folded. This is 15 centimeters under the limit of the almost the biggest airplanes category E, usual for the 777s. The rest of the high lift devices are not as exotic. Big flaps, slats extended throughout the entire wing, ailerons and spoilers. More or less the same stuff you find on other planes. Rather simple, but still beautiful. The empennage is also almost entirely made of composite materials, and features lots of solutions found on the Boeing 787. But only to a certain extent. It has a somewhat simpler design. For instance, the hybrid laminar flow control systems on the tail stabilizers developed on the Dreamliner don't seem to be used here. Laminar surfaces are used on the engine nacelles, which, considering their size, improves the aerodynamics. What's interesting is that in spite of all this fiddling with the structure, the maximum takeoff weight of the Boeing 777-8 and 9 is the same as that of the 777-300ER, about 351 tons. Technically, that is quite possible. The airplane got bigger and heavier by itself, but at the same time its structure got less dense, and its efficiency allowed to reduce the amount of fuel needed. But it is still hard to believe that the figure turned out to be exactly the same. Perhaps this has to do with some certification or operational specifics, or it might have to do with the capabilities of the landing gear, which was barely changed. Or maybe there is some symbolic mysticism to all this. 351.52 tons is roughly 777,000 pounds. Finally, we come to the burning heart. One of the particularities of the 777 is the killer ratio between the impressive size and weight of the aircraft and the fact that it has only two engines. From the moment of creation, these engines were record-breaking with their huge size and corresponding thrust. But the truth is that it also created a problem. Such engines are incredibly complex and expensive, and while the first-gen 777 had the engines from Rolls-Royce, Pratt & Whitney and General Electric, the second generation was left only with GE, with their mammoth GE90. The same happened to the new generation. Only the General Electric brainchild will reign under the wings of these giants. On one hand, this leaves the operators without options, but on the other, it allows to reduce costs. Besides, it's not like there are lots of alternatives. Yet. Of course, considering the times we are living in, the GE90 had to be updated quite extensively. Cost efficiency was mostly achieved using the old and tried trick, by increasing the bypass ratio. GE9X got a 340cm or 134 inches wide fan, which is 10 cm more than that of the GE90. This made the already huge engine even bigger. The size of this monster is well pronounced when you see it hanging under the wing of the Flying Testbed 747, by the side of the standard jumbo jet engines. The fan by itself is a masterpiece. It is made up of only 16 huge composite blades, which allow to reduce the engine's weight and increase the rotation speed. But this was not enough. The already huge fan could not be enlarged by much, even those 10 cm required a considerable effort. In order to increase efficiency, the aviators adopted some technical solutions that had been tested on the CFM LEAP engines. First of all, they made the already tough spools even more active. The tuning was applied mostly to the high-pressure compressor, which got as many as 11 stages. To keep an even higher pressure and temperature, all the elements had to be reworked, implementing more heat-resistant alloys and ceramic composites, as well as mastering the 3D printing of some components. The result was obvious. The compressor reached an overall pressure ratio of 60:1. This is quite a wild figure, as the GE90 has a ratio of 42:1. At the same time, the bypass ratio grew up to 10:1. I purposefully did not bring up the topic of power. The usual operational thrust of the GE9X engine is 470 kN, which is a bit disappointing because the older GE90 from the 777-300ER model generates as much as 513 kN. The calculation showed that 470 kN are more optimal for the new airliner. However, during the limit performance testing, General Electric managed to squeeze out of this engine 596 kN, 134,000 pounds or 60 tons of force. The record is official. This is the biggest and the most powerful jet engine ever made. GE confirmed their awesomeness, and at the same time, they showed the prospect of forcing the engine. Yet another interesting challenge was the avionics. On one hand, it had to be cutting edge. After all, it is a flagship airliner. On the other hand, the continuity of generations had to be preserved, along with the closeness to the other planes of the company. The mission was more or less accomplished. In terms of controllability, the 777-9 had to resemble the 777-300ER, while most of the ergonomic solutions were adopted directly from the 787, including the cockpit design, instrument positioning, seats, and head-up displays. Essentially, Boeing ends up having two families of wide-body airliners with practically identical cockpits, which simplifies both the manufacturing and aircraft operation. Still, there are some innovations. The interface is made up of 5 large 15-inch displays. At first glance, everything is familiar. The same can be seen on many modern airliners, with the exception of one aspect. All of these displays are touchscreens, full-grown sensors supporting multi-touch like on a tablet. This is supposed to make the controls more intuitive and reduce the number of instruments. This really is quite an innovative solution. Even the new interfaces are controlled at best by cursors, while the touchscreens are used on secondary instruments. But let's be honest, sooner or later we were bound to see this. The majority of the remaining upgrades here are related mostly to the expansion of the possibilities of automation, takeoff and landing aids, advanced navigation, and autopilot. Boeing remains loyal to its traditions, and despite the implementation of new solutions, the classic yokes are still proudly standing on their place. All of these solutions are supposed to make the Boeing 777X a new leader. The main bonus of the efficiency found in the airliners of the new generation are of course their engines, that should provide a 10% reduction of operational costs and emissions. Better alloys and composites, along with the improved aerodynamics and weight reduction, make quite a contribution. The competitiveness is also boosted big time by the increased capacity. The amount of fuel burned per seat, according to Boeing, can decrease by 20% compared to the previous generation. Of course, the guys from Seattle don't forget to mention their main competitor, and emphasize that the Model 8 will be 4% more efficient than the A350-1000, and the Model 9 as much as 11%. Real-life operation by airlines will show if these statements are true. That is, of course, if the airlines will share such data. Let's take a quick look at the existing and planned modifications. By now, there are two main models of the airplane, the 8 and 9. The Boeing 777-9 is the basic model of the 777 family of the third generation, and for now, the bigger brother. This aircraft is meant to replace the 777-300 airliners, but it is longer and has a greater capacity. Since this is the basic model, it was a starting point. All of the initial prototypes were the 9s. The Boeing 777-8 is a shorter version of the Model 9 that can be considered the successor to the 777-200 and is presented as the main competitor to the A350-1000. It is quite possible that there will be a version with an extended range, so it could compete with the A350 ULR. This should be a Model 8 airliner with an increased maximum takeoff weight due to it carrying more fuel and with range exceeding 17,500 kilometers or 9,400 miles. The plan was to launch the 777-8 model a couple of years after the Model 9. But taking into consideration the current circumstances, most probably this will happen closer to 2023, and its modifications will come out only by the middle of the decade. This, with all the prospects, is leaving Boeing without the time to take its place in the ultra-long-range flights niche, which is being actively seized by the A350 ULR. Of course, just like the cargo 777F was made on the basis of the 777-200LR, similarly the 777XF or 8F should be based on the Model 8. Its specifications are unknown by now, but most probably they will be close to the current freighters, with a better economy. 777-10. For now, this is a purely theoretical project of a stretched version of the Model 9. An 80 meters long aircraft capable of taking in 450 passengers in a two-class configuration has the potential to compete with the four-engine flagship airliners, the Boeing 747 and A380. Considering that these dinosaurs are obviously losing positions, the demand for a new airliner may quite possibly arise, and if that happens, the rest would be just a formality. And obviously, the BBJ 777X, the super VIP jet that can be created on the base of the mass-produced airliners. With cabins as large as 302.5 and 342 square meters, and ranges of 21,500 and 20,400 kilometers respectively, the BBJ 777-8 and BBJ 777-9 can become a new definition of the word excess. Let's get back to the adventures. In spite of a certain degree of conservatism, this aircraft required quite a considerable modernization of the production lines. The main step was to build a large plant for composite elements in St. Louis. As a matter of fact, this is quite a step forward for the locals. When building the 787, many of the elements came to the US already assembled in Japan. Now, in the case of the 777s, the degree of localization is increased. The final assembly is carried out in Everett, Washington, the motherland of the 777s, where the production site also had to undergo a considerable modernization. The arrangement of production turned out to be a real industrial dance for Boeing. In the years to come, they will have to maintain a simultaneous production of the second and third generation airliners. Plus, the conversion of passenger planes into cargo freighters is a popular option. These are old ideas. With the current crisis and plummeting demand for the airliners, the production rate will most probably have to be reduced. Previously, the company would maintain a production pace of 5 planes per month, but now it's planned to be reduced to 3. The project development was not going smooth either. Ground tests of the GE9X engines revealed a series of issues, and the necessary tweaks delayed the flight tests of these engines on the Boeing 747 testbed. As if that wasn't enough, there were also difficulties with setting up production of the airliners themselves, all of which had to be solved quickly. The schedule was already stretching like rubber, which was not thrilling for the customers. The rollout ceremony for the first prototype took place in March of 2019. It was a humble event that was mostly attended by the company employees. After the crashes of the 737 MAX airliners, it wouldn't be right to show off too much. On the other hand, the event was important. Boeing had to prove to everyone that, in spite of all the problems, the company is alive and moving forward. The next pothole in the airliner's past was the fact that the airframe that was supposed to crash under maximum overloads did crash, but not at maximum. On the final testing stage, the fuselage did not withstand and basically burst open, leaving a huge hole in the hull and ejecting the tail door. When creating the 777X, Boeing was trying to bring its comfort to the level of 787. As it turned out, it is not that easy to achieve the capabilities of a composite fuselage on an aluminum one, and in some points, its strength just wasn't enough. Apparently, the aviators decided that there is no need to repeat the tests, and they have enough data to understand what part of the structure needed to be reworked in order to achieve the desired specifications. The situation is a bit unsettling. On one hand, there were cases with rushed certification and tragic results. On the other hand, the airframe did withstand 99% of test stress load. And in reality, in order to face that kind of structural stress, you need to put the airplane in some infernal flight conditions. In any case, Boeing is now in crosshair of everyone interested in aviation, so I doubt that the company will be taking any new risks. The 777-9 model made its maiden flight in January 2020. The aircraft took off from the Payne Field Airport at the Everett plant, and after spending 3 hours and 52 minutes in the air, it landed at the Boeing Field Airport in Seattle. The second prototype took off on April 30. The third plane is already undergoing pre-flight ground tests, and the fourth one should join the party soon. In total, 6 prototypes should take part in the flight tests, 4 aircraft of the version 9 and another 2 of the version 8. We should be able to see the whole team by 2022, which is when the shipping of the Model 9 to the customers should already start. The catalog price in 2020 reached $410 million for the 777-8 model, while the 777-9 has a price tag of $442 million, which makes it one of the most expensive airliners to ever be produced by Boeing. Even the 747-8 turned out to be cheaper. Yet even with such prices, Boeing has an ordered portfolio of 309 airliners for 9 operators. Naturally, most of them are bound to be delivered to the Middle East and Asia. The European customers are Lufthansa and British Airways, which are looking to replace their older Boeing 747 and A340s. What's curious is that the airlines from America are nowhere to be seen in that list. The era of the 4-engine mammoths is becoming a thing of the past, and their heirs, the twin-engine giants, are starting to reign the skies all over the world. Their size, capacity, comfort, range, and reliability are already becoming mundane, even though not long ago they seemed amazing. And the flagship of this new era in the beginning of the 21st century will be precisely the Boeing 777. Well then, long live the king! Like and subscribe to the channel so you won't miss out on any stories that are waiting their turn. Fast flights on big and awesome airplanes and soft landings to you.